Scan the brains of a genius and an average person solving the exact same hard problem, and watch what happens to the genius's brain. You already know what you'd expect. The genius's brain blazing, firing on all cylinders, burning bright, while the average brain quietly ticks along. That's what everyone assumes, but it's the exact opposite, because when scientists actually ran this experiment, the genius's brain did something that made no sense at first. It went quieter. It used less energy. The harder the problem got, the calmer the brilliant brain became. And that one backwards finding cracks open everything we get wrong about intelligence. So let's put these two brains side by side and really look, because what separates them isn't what you think, and it's a lot stranger. We picture genius as horsepower, more neurons firing, more brain lighting up, a bigger engine roaring louder than everyone else's. It's such an intuitive idea that it gave us the most famous brain myth of all time, that geniuses use more of their brain, while the rest of us only use 10%. Let's kill that myth right now, because it's completely false. Every healthy person uses 100% of their brain. Einstein used 100%. You use 100%. The difference between a genius and an average person was never how much brain gets used. It's how the brain is built and how efficiently it runs. And to see that, we have to go inside. Start with the finding that started it all. In 1988, a neuroscientist named Richard Heyer put people inside a PET scanner, a machine that measures exactly how much energy, how much glucose, each part of the brain is burning in real time. Then he gave them a hard, abstract reasoning test and watched which brains lit up. And the result was so backwards he had to double-check it. The people who scored highest, the sharpest minds in the room, were burning the least fuel. Their brains were the quietest. Meanwhile, the people who struggled had brains lighting up all over the place, burning energy everywhere, working furiously hard. Read that again. The smart brain wasn't working harder, it was working less. And it was winning. This is called the neural efficiency hypothesis. And once you understand it, genius stops looking like a bigger engine and starts looking like a better one. Picture two people trying to reach the same address. The average brain is someone who doesn't know the city, so they light up every street, take 6 wrong turns, double back, ask for directions, burn a whole tank of gas and eventually arrive. The genius brain already knows the one clean route. It takes it, quietly, using almost nothing. Same destination, a fraction of the fuel. Intelligence, it turns out, isn't about how loud your brain can get. It's about how much of the noise it's learned to switch off. But here's where it gets stranger, because if that were the whole story, you'd think geniuses are just born with a quiet brain, and that's that. It's not that simple, and the proof came from a video game. In 1992, Heyer's team scanned people's brains, had them play the game Tetris over and over for weeks, and then scanned them again. At the start, while everyone was bad at it, their brains were blazing, energy everywhere, fighting to keep up. But after 50 days of practice, something remarkable had happened. As they got good, their brains got quiet. Same people, same game, but now their brains sipped energy instead of guzzling it. Their brains had physically learned which regions were useless for the task and shut them off. So neural efficiency isn't only something you're born with, it's something a brain builds by mastering something. Every time you get genuinely good at anything, your brain quietly lays off the workers it doesn't need and streamlines the ones it does. Expertise, at the level of the brain cell, looks like silence. So a genius brain is quieter and more efficient. But quieter doing what, exactly? For that, we have to look at the wiring, and at the most studied brain in human history. When Albert Einstein died in 1955, a pathologist removed his brain, and scientists have been studying it ever since, hunting for the secret. The first thing they found was the thing nobody expected. It was completely average in size, slightly below average even. Whatever made Einstein Einstein, it was not a bigger brain. What they found instead was in the details. Parts of his parietal lobe, a region tied to mathematical and spatial thinking, exactly the kind of thinking he was famous for, were unusually shaped and unusually developed. And his corpus callosum, the thick bundle of fibers that connects the left and right halves of the brain and lets them talk to each other, was thicker than average. His 2 hemispheres were wired to communicate better. And that points at the deepest difference of all. Because intelligence doesn't actually live in any one spot in your brain, there's no genius gland. What modern neuroscience keeps finding is that intelligence lives in the connections, specifically in how well the front of your brain, which plans and reasons, talks to the parietal regions, which handle information in space. This front-to-back highway is called the frontoparietal network, and in more intelligent people, it's better connected. The signals travel faster and cleaner because the wiring is wrapped in more of a fatty insulation called myelin, the same stuff that turns a slow, leaky wire into a high-speed cable. A better myelinated brain literally transmits thought faster. So the real difference between a genius brain and an average one was never about having more parts. It's about having better roads between the parts. A genius brain isn't a bigger city. It's a city with faster highways and less traffic. So let's put the two brains back side by side and now actually see them for what they are. Hand them both the same hard problem. The average brain lights up loud and wide, firing across regions it doesn't even need, burning fuel, muscling toward the answer through sheer effort. The genius brain barely stirs, a quiet, precise flicker along a few well-worn, well-insulated routes, solving it while spending almost nothing. One brain is shouting, the other is whispering, and the whisper is winning. But here's the part I want to leave you with, because it's the part that actually matters for you. The Tetris study proved the quiet, efficient brain isn't only handed out at birth. It's partly built, carved by deep, repeated practice at something hard. Every time you push through the clumsy, effortful, energy-burning stage of learning a skill and come out the other side fluent, you are physically doing to your brain a smaller version of what makes a genius brain efficient. You're not going to become Einstein by practicing, but the direction, quieter, faster, more efficient, better connected, is a direction any brain can move in. Genius is a way of being wired, and your wiring is not finished. So the next time you picture a genius, don't picture a brain on fire. Picture the calmest brain in the room. If this changed how you think about your own mind, tell me in the comments. What's the one skill you've practiced so much it now feels effortless? That's your efficient brain, and you built it. Subscribe if you want more of the mind explained properly, and I'll see you in the next one.